Out of 50, our next question is 27th question, phasor relation with purely inductance. So here I have taken only one inductor. So across this voltage source, there is no any other passive elements. Across this inductor, the drop voltage is VL. Okay, so the flow of current is I. The same formulas we are taking here also, V equal to Vm sin omega t. So already we know that according to inductance, so we have one short video in inductance, that formulas you have to refer, then you will get the same formulas. V is equal to L into di by dt. So from that, L into di by dt equal to Vm sin omega t, this Vm sin omega t, V place only we can replace this L into di by dt. Okay, so here V equal to Vm sin omega t. So V place we can replace L into di by dt, inductance value. So already we have written inductance formulas and inductor definition, previous question, short answer, you have to refer that. Okay, inductance capacity and change of the current with respect to time period. Okay, so we can take here di. So it's mean from this we need a current value. Already we define a voltage value, we need to define here current value. That's why di only we can take here, and remaining these dt and L we can send to this left hand side. Then we can get it Vm by L into sin omega t. Then I equal to this differentiation we can send to right hand side. In essence we can get that we can convert that one into integration. It's mean that differentiation is converted into integration. So I equal to Vm by L, so integration sin omega dt. So I equal to Vm omega, here you remember always omega t we are getting here, because integration we done for this sin omega t, in the sense that one is a minus cos omega t, but we are doing this integration only with respect to time period, but here omega is there now, so that omega we can get it here, so that omega only we can add here. Okay, Vm by omega L into minus cos omega t, you can get it. Now equal to Vm by omega L into sin omega t minus pi by 2. Why minus pi by 2 we are taking, in the sense here we got cos omega t, that cos omega t we can convert it into sin omega t minus pi by 2. It's mean this one is a sin omega t minus theta. Okay, so that formula you have to remember. Okay, then this minus also converted into plus, positive here. So I equal to Im sin omega t minus pi by 2. So here I mean Im equal to Vm by omega. The same formulas we got in our lagging also. Same formulas we got lagging also. Okay, and waveform also same, you remember. In lagging condition, whatever the waveforms we got, the same waveforms we got it here. We observe that purely inductive circuit, the current lags behind the voltage by 90 degrees. So where started current source, actually here 0 point, and at a peak voltage point we can get it maximum voltage. At this maximum voltage point current started. It's mean where maximum voltage is there, at that particular condition current is 0. So that one is at exactly a 90 degrees. So that one only the phasor diagram we drawn here. Voltage is maximum, that's why only behind this current value, it's mean in a upper side, and this current is lags with 90 degrees. Okay.